Fair warning, you all are getting the B team today. I was notified on Sunday night that I was to give this speech. Cole had a family thing that he had to go out. So if you all are here for Cole Crawford, you are out of luck. My name is Alan Bach, and I run corporate development and business development for Vapor.io. And my talk today is really about the transition from general AI inferencing to specialized AI inferencing. And you can see on the screen here, we have just announced a product called ZeroGap, which is our entree into this specialized inferencing stage. So I'll start off with a comment that has quickly become a cliche in the AI industry. Training takes money and inferencing makes money. So the training is obviously the accumulation of knowledge, but inferencing is what you do with that knowledge, the decisions and the value that you add to the market. We are starting to see, I don't want to say the beginning, but really starting to see the upswing, the hockey stick of the AI inferencing model. More and more deployments are going out on-premise, near-premise, and back in centralized data centers. And then on the bottom there, you can see our own announcement that just came out last Wednesday. And I'll go into that a little bit deeper. So general AI is, honestly, it's my dad. If you asked my dad any question, no matter what it was, you were 100% guaranteed to get an answer. And for the most part, it was directionally correct on any subject. General AI is designed to mimic human intelligence. It's very versatile, adaptable, and broad in scope. It combines the reasoning, problem solving, learning, and so forth, and it's excellent for applications such as natural language interaction, music composition. Obviously, I don't need to tell you all everything that's going on with chat and Sora and Midjourney and so forth. But the limitations are such that it's a jack of all trades and a master of none. And so it only gets you so far. In addition to that, because it has to be ready for everything, it's very resource intensive and relatively speaking slow. An example of its limitations are if you were to do medical diagnoses for cancer or anything else, general AI is not going to meet that need. So that leads us into specialized AI. So if I want to carry that analogy a little bit further, my dad is a dentist. So if I were to go to him with an actual question about my toothache, he would be able to rely on all of the knowledge that he has gained in that specific narrow field to tell me that I need a root canal. And very similar to specialized AI. It's engineered to perform specific tasks, and it has been enabled by advances in algorithms, advances in chip architecture, specifically designed for applications in certain areas. And you see different types of GPUs being deployed for different types of specialized inferencing tasks. And again, an example would be that cancer diagnosis or in smart city applications, pedestrian safety, traffic management, fraud detection, things like that. The benefits are that it's a much more narrow and accurate decision that can be made. It is much less resource intensive. And it's an enhanced user experience because that user is getting the answers that they need. So what you're looking at here, you don't need to go into specifics, but this is one example of research that has come out talking about the specialized AI inferencing market. Very specific verticals that you see here: smart city, healthcare, manufacturing, robotics, that sort of stuff. And again, as I mentioned, we're right at the cusp of the hockey stick increasing now that a lot of the training has been done. So my company, if I'm assuming you all are not familiar with us, We started out as a distributed edge compute platform with micro data centers being distributed around a metro area and then connected via fiber for a very geographically dispersed but logically condensed data center environment for real-time applications such as autonomous driving. Now, with the advent of AI, we just announced a product which, with our partner Supermicro, we are deploying large-scale, high-capacity GPU infrastructure in these distributed data centers. And so we will be enabled, and that will be offered on an as-a-service basis, akin, well, it's not akin, it is a cloud model for real-time, near-premises AI inferencing and training. It's a full-stack solution, meaning that we have the GPUs, which we can offer as a service. We can also have canned AI reference architectures, computer vision, things like that, that people can take advantage of. We have the networking included in that. And then finally, we are going to have an integrated 5G core and RAN because you have to be able to collect the data from either locations that are on wired or wireless networks. So the thing about specialized AI that we can do is we can look at a city and we can determine what types of AI inferencing we want to place at certain areas in a city. And what you're looking at here is a map of Las Vegas. And so up in the top, you can see light industrial, you see downtown, you see the strip and retail, and then the airport and other industrial down below. So by having our distributed footprint, we can then take these ZeroGap deployments in our data centers and place them where they're most needed. The reason that each one of these has a diameter around it is that gives a certain amount of latency via fiber for 5G applications. And so if anybody is familiar with 5G, there are very stringent latency thresholds if you're doing DU aggregation and so forth. And the key about our deployment is that both the 5G workloads and the AI inferencing will be running on virtualized GPUs at the same time. So it maximizes the efficiency of that very expensive gear. You can look at this both on a vertical basis. You can look at specialized AI on a vertical basis or a horizontal basis. Vertical, many of the same verticals that I mentioned before: healthcare, logistics, manufacturing, hospitality. Smart cities is one that has been in the news for the last 20 years and is finally coming to fruition. One of the things that we're doing with the city of Las Vegas is taking their domain-specific data sets, i.e. video and LiDAR from cameras that are placed around the city, and then running those through our own inferencing models for things like pedestrian safety, for traffic queuing, for terrorist threat, that sort of stuff, public safety. You can also look at it on a horizontal basis. Specialized AI is very good for robotics, for cameras, and also I mentioned here the 5G aspects of it. So where's all this stuff go? So with specialized AI, the cool thing that we're just starting to get involved in is the cross-pollination of these domain-specific data sets. You can think of a situation here where Texas just finished playing Alabama, everybody's leaving. You know, based upon your analysis, that roughly 50% of the people are going to be heading to North Austin. Now you can couple that with data that's coming from 35 and, I don't know, some northern cross street where there's an accident. And now you can combine those two inferencings to create very predictive types of applications where you can tell these people, hey, it's much better to travel west, get on 1, to avoid 35, which is going to happen. It's a very simplistic example. I know anybody can look at Google Maps and see the same thing, but hopefully you get the general sense. There's also research into meta-learning, which is really learning how to learn. And so it'll be very interesting to see how these AIs are starting to couple together cross-domain types of knowledge to create decisions, such as using information gathered from gaming and being able to utilize it in business metric decisions, things like that. Probably a lot like war games, where they were using chess to teach thermonuclear war. The challenges that we have are that we really need to create high quality domain specific data sets. And so what I think you're going to see is a lot of work being done to take cities' data sets, clean it up. I'm sure industry associations will start to gather anonymized data from their specific industry, such that you have a clean, wide data set. An example, I went through those. Some of the other challenges are to make sure that you're balancing the specific use case decisions against the adaptability and versatility. You don't want to be too narrowly focused. This would also lead into the potential for biases to come up in narrow data sets, and we need to be very careful about taking those biases and including them in certain applications, inferencing applications, such as recruitment for specific industries. And then my final thoughts, and I'll leave you here, and we can open it up for questions. We need a continuous innovation in this realm. A lot of potential exists in here, and there's a lot of work being done on specific applications. And again, that balance is how to, or the balance that we need to achieve is specification versus adaptability. Obviously, there's a lot of ethical considerations to be had too, job displacement, privacy issues. And then we also need to look at the policy side, ensuring that this data is not misused, privacy is being protected, and that there's not racial discrimination or other types of discrimination being used in these applications. And so that's it. I'll go ahead and open it up for questions, if any. Nope.
Yeah, hopefully you can hear me. So my question is, will you have like specific nodes or pods for specific tasks, where maybe you have like kind of like how you have agents that are specialized? You maybe have like hardware layers that are specialized, maybe one for vision processing, the other for like some type of like secondary summarization, or large language model layered on top of that. Is that how you're thinking about some of the infrastructure?
Yeah. And talk up, the question was really around, are we going to have specific infrastructure for certain applications around an area? The initial deployments that we will have will be, for the most part, general, but they will be Grace hoppers, they will be H100s, and they'll also be L40Ss. So there are different tasks associated with each of those. However, as I mentioned in that map, as we go into a metro area and we want to go after heavy industrial, we would absolutely start to focus certain types of deployments in that particular area, as well as the rest of the city. Did that answer your question?
Yeah, just curious.
Yep.
Yeah, I just wanted to ask, when speaking about these deployments very locally, co-located in an area, can you give us more specific use cases as to why it wouldn't be better just to have a singular data center, and why we need fiber, within a mile of a location of your data center?
Yep. Sure thing. I think the question, if anybody didn't hear it, was around why make these hyper-local as opposed to set back for regional data centers or large IX. There are many applications that require extremely low latency Computer vision, if you wanted to do certain things like autonomous vehicles or connected vehicles, things like that, you're really talking about decisions that have to be made on the order of 5 milliseconds. And sometimes you can get that by going to a regional data center, but the tail of that distribution is what's going to kill you if it goes down. So by having it much closer, you get a much more performant network, and you can meet those latency thresholds. As I mentioned to you before, too, a lot of the applications that will be driving, a lot of the applications that will be driving these next generations, though, will be done over 5G. And so 5G requires accelerators. Right now, if you deploy an accelerator on-prem, that accelerator is just dedicated to your 5G network, and you're losing a lot of the efficiency and capacity in that accelerator while you're doing the AI inferencing maybe back in that regional data center. By combining those two things, you're near-prem, you can do both of those on the same accelerator, with the 5G requiring, on the order of less than a millisecond of latency. Did that answer your question? Yeah.
Are you going to be selling tokenized API inferencing, or are we going to be deploying our own clusters into your system?
Yeah. So this is where the whole B team thing happens, right? So I'm going to answer your question, but with the caveat that my background is finance. Right now, when we initially roll this out, it's going to be akin to bare metal, and then eventually it will go to virtualized GPUs. Probably the lowest segment will be around an hour. However, in our discussions with NVIDIA and Supermicro, we definitely want to move towards that tokenized inferencing. Did that answer your question? Oh, awesome. But that is definitely in the game plan. Yeah.
I'm generally curious on your targeting applications that have zero downtime. How would you have redundancy while also making sure your database doesn't have any lag?
Yeah, that's a great question. It's almost like I planted you there. If you're building at the far edge, you cannot build massive data centers with fault-tolerant, 2N types of structures. So our deployment, our data centers, which are connected via our own fiber network, is really designed to allow for distributed resiliency. And so you're talking about active in multiple locations around a city, with obviously with UPS up there, but we also provide a lot of telemetry into an orchestrator around what's going on with that particular data center, be it is it on secondary power, or is there something going on with the HVAC unit, so that we can proactively use an orchestrator to move those workloads around that metro area. And while you might not get the same latency, you're not going to have downtime. And so we've done a study that if you have active in up to 3 or 4 different locations, I think you're somewhere on the order of 10 nines of uptime. So we call it engineered to be 100% uptime. Oh, one more. All right.
This seems very capital intensive.
This is why having partners like Supermicro and NVIDIA are very important to this whole thing. It is very capital intensive. We have already built out, in terms of the data centers and the fiber, we've already built out 36 U.S. markets. We've spent the last 5 years doing that. And now we have our partner Supermicro and NVIDIA helping us to come in with this infrastructure. So we're very excited about that.
Do you already have use cases with customers?
Yeah, we're starting to. So the initial deployments of ZeroGap, again, was announced last Wednesday. But we have customers that have already come in, and now it's just a matter of getting the infrastructure deployed and out there. So we're having very good conversations and we go to market through channels. And so those channels are looking at this saying, hey, this is fantastic. We can create an as-a-service product offering on your platform. All right, is that it? Thank Thanks for your time today. Appreciate it.